we are covering geometric design for the FE Civil exam, focusing on stopping sight distance and superelevation. These are fundamental concepts in roadway design and are frequently tested. Let's start with stopping sight distance, or SSD. You'll find the primary formula in the Transportation Engineering section of your NCEES FE Reference Handbook. SSD is the total distance a vehicle travels from the moment a driver detects a hazard to the moment the vehicle comes to a complete stop. It's composed of two parts, the perception reaction distance and the braking distance. The formula is SSD equals 1.47 times V times T plus V squared divided by 30 times the quantity of F plus or minus G. In this US customary formula, V is the design speed in miles per hour, T is the perception reaction time in seconds, F is the coefficient of friction for braking, and G is the roadway grade expressed as a decimal. Here's a typical exam-style problem. A vehicle is traveling at 60 miles per hour down a 4% grade, assuming a perception reaction time of 2.5 seconds and a friction factor of 0.3. What is the stopping sight distance? First, calculate the perception reaction distance. 1.47 times 60 miles per hour times 2.5 seconds, which equals 220.5 feet. Next, the braking distance. This is where the most common exam trap occurs, the sign of the grade, G. Since the vehicle is going downhill, gravity is working against the braking effort, increasing the required distance. Therefore, you must subtract the grade. The braking distance is 60 squared, divided by 30 times the quantity of 0.3 minus 0.04. This calculates to 3,600 divided by 30 times 0.26, which gives 461.5 feet. The total SSD is the sum of these two parts, 220.5 plus 461.5, for a total of 682 feet. If that problem had said uphill, you would have added the grade, resulting in a shorter braking distance. To avoid this trap, use this mnemonic. Uphill is a plus. When you're going uphill, gravity helps you stop, so you add the grade in the denominator. Now, let's shift to horizontal curves and superelevation. Superelevation, or E, is the banking of a curve to help vehicles safely navigate the turn by counteracting centrifugal force. The governing equation, also in the transportation section of the handbook, is E plus F equals V squared divided by the quantity of 15 times R. Here, E is the rate of superelevation, F is the side friction factor, V is the vehicle speed in miles per hour, and R is the curve radius in feet. Notice this F is for side friction, not braking friction from the SSD formula, a common point of confusion. For example, a horizontal curve has a radius of 1,500 feet and a design speed of 65 miles per hour. What is the required superelevation rate if the side friction factor is 0.12? Plugging into the formula, we get E plus 0.12 equals 65 squared divided by 15 times 1,500. This simplifies to 4,225 divided by 22,500, which is 0.188. Solving for E, we subtract 0.12 from 0.188, yielding a superelevation rate of 0.068, or 6.8%. Exam questions may also test conceptual limits. Most agencies cap the maximum superelevation, often around 6 to 8% in snowy regions, to prevent slow-moving vehicles from sliding down the slope, and up to 12% in other areas. If your calculation results in an E greater than the stated maximum, the design is not feasible and would require a larger radius or a lower design speed. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.